Get ready to discover the fascinating world of computer architecture. Our goal today is to help you understand the key differences between RISC and CISC. How would you go about it? Well, let me tell you. With some simple and easy-to-understand explanations, you can master this concept without breaking a sweat. We'll guide you through the differences between RISC and CISC with clarity and simplicity. By the end of this video, you'll be able to differentiate between them like a pro. So stay tuned and get ready to ace your exams with ease. Let's get started. First, we'll tackle what RISC is all about. RISC stands for Reduced Instruction Set Computer. As the name suggests, it uses a smaller set of simple instructions. Each instruction is designed to perform a single, specific task. For example, load, add, and store data. These instructions are straightforward and easy to execute, allowing the CPU to complete each instruction in just one clock cycle. That means faster, more efficient processing. Now let's visualize this concept with an analogy. Think of a chef following a recipe. The chef has a limited set of tools in their kitchen, just like the CPU has a reduced set of instructions. With these tools, the chef can prepare a variety of dishes. Much like the CPU can handle various tasks using its instruction set, each step in the recipe represents an instruction that the chef executes in sequence to create the final dish by breaking down the task into smaller, simpler steps. RISC enables the CPU to work more efficiently and quickly. Next, it's time to explore CISC, which stands for Complex Instruction Set Computer. Unlike RISC, CISC uses fewer instructions, but they are more complex. These instructions can perform multiple tasks in a single step. For instance, an instruction can load, add, and store data all at once. While this reduces the number of instructions, it increases the complexity of each one. As a result, completing a task may take longer because the CPU has to process multiple steps in a single instruction. Let's use the analogy of a tightrope walker to illustrate CISC. The tightrope walker has a smaller set of moves, but they are more challenging and time. Each move involves multiple steps that the walker must execute in perfect coordination. For example, the tightrope walker might pick up a weight, walk forward, then shift the weight to the other side while balancing. This single move involves several actions that test the walker's skill and balance. Similarly, a CISC processor handles multiple steps within a single instruction, increasing the complexity of the operation. Now let's see a side-by-side comparison of RISC and CISC to highlight their differences. RISC has a reduced instruction set, meaning it uses more instructions to complete a task. Each instruction is simple and fast, though taking only one clock cycle to execute. In contrast, CISC has a complex instruction set with fewer instructions. While this simplifies the code, each instruction is slower to execute as it involves multiple steps. Overall, RISC is faster and more energy efficient, while CISC is more powerful but less efficient. Let's look at some use cases for each architecture. RISC is commonly used in mobile devices like smartphones and tablets due to its speed and efficiency. It's also popular in embedded systems like IoT devices. On the other hand, CISC is often found in laptops, desktops, and Intel-based servers. Here's a quick summary of the pros and cons for each architecture. Starting with RISC. The advantages include simpler hardware, faster processing, and power efficiency. On the downside, it has a larger code size and may require more RAM. Now for C. The pros are shorter code and easier execution of complex instructions. The cons are slower performance and higher power consumption. Finally, let's discuss the history and evolution of RISC and CISC. RISC gained popularity in the 1980s with the IBM and ARM. CISC, on the other hand, dominated the market with Intel's x86 processors. However, both architectures are still widely used today depending on the specific application or device. And there you have it. We've covered the basics of RISC and CISC, including their definitions, characteristics, use cases, and history. Remember that both architectures have their own strengths and weaknesses, and the choice between them depends on the specific requirements of the project. Whether you're working on a mobile app, a desktop software, or anything in between, understanding the differences between RISC and CISC can help you make informed decisions about which architecture will best suit your needs. That's all for now. If you found this explanation helpful, please hit the like button, share it with your friends, and subscribe for more tech. Thanks for watching, and happy coding!